Welcome to the Java programming series for ICSE Class 10. In this unit, titled Class as the Basis of All Computations, we explored how Java classes can be used for real-world logic. Our subtopic for this lesson is calculating wages using a class, security, where we'll write a program that takes hours worked and rate, and computes wages for security personnel. Let's begin with program, class security. In this program, we're asked to create a Java class named security, which simulates the process of calculating wages for a security guard based on the number of hours worked. The class must contain 4 instance variables. N is a string variable used to store the name of the employee. H is an integer that keeps track of the total number of hours worked in a week. R is a double that holds the hourly wage rate. W, also a double, will store the total wages calculated based on given logic. Along with the variables, the class must also contain 3 member methods. The get method will be used to accept input from the user, including the employee's name, rate per hour, and total hours worked. The call wage method will perform the wage calculation. This involves checking how many hours were worked and applying the correct rate. Wage calculation logic is explained in next slide. The display method will then output the final results in a clear and formatted way, showing the name, number of hours, and total wage earned. One very important condition mentioned in the problem is that the employee should not work for more than 70 hours in a week. If the input exceeds 70, the program should display an error. So overall, this problem gives us a great chance to practice Java class structure, user input, conditional logic, and formatted output, all within a real-world scenario. Let's now understand the logic we'll use to calculate wages in Java and how the final result should be displayed. First, we apply a tiered wage structure. If the security guard works 40 hours or less, the wage is calculated simply as the number of hours multiplied by the hourly rate. If the total hours are between 41 and 60, then the first 40 hours are paid at the base rate, and the extra hours, that is, hours beyond 40, are paid at 1.5 times the hourly rate. If the hours fall between 61 and 70, the first 40 hours get the base rate, the next 20 hours are paid at 1.5 times the rate, and any additional hours above 60 are paid at double the rate. However, if someone enters more than 70 hours, the program must show an error message and not perform any calculation. Once the wage is calculated, we need to display the result. The output should clearly show the name of the person, the total hours worked, and the final wage in a currency format with 2 decimal places. Here's a sample output. Name. Hours. Wages. This is exactly how your program should display the results on the screen. So this slide explains both the logic to calculate wages and the format for displaying the output, which are key parts of your Java program. The algorithm involves reading input using a scanner in Java. Then, we apply conditional logic to calculate the wage. The output is displayed using system.out.print for neat formatting. Let's now look at the get method, which is responsible for taking input from the user in our Java program. First, we create a scanner object using the line scanner sc equals new scanner system.in. This allows us to read different types of inputs from the keyboard, strings, integers, and decimal numbers. Then, we use system.out.print to prompt the user for inputs one by one. First, we ask for the name of the security personnel. This is accepted using sc.nextLine and stored in the string variable n. Next, we prompt for the hourly rate. Since it's a decimal value, we use sc.nextDouble and store it in the double variable r. Finally, we ask for the number of hours worked in a week. This is an integer input, so we use sc.nextInt and store the value in the integer variable h. This method prepares all the necessary inputs that will be used later to calculate the wage. Also remember, scanner is part of java.tutil, so the import statement import java.tutil.scanner must be placed at the top of the Java program. In summary, the get method is where the program interacts with the user, gathering all the required information to proceed with the computation. Now let's understand the call wage method, which is the heart of the program. This method performs the actual calculation of the wage based on the number of hours worked. The method uses if-else statements to handle different cases according to the rules provided in the question. 1. First, the condition if h greater than 70 checks if the hours worked are more than 70. If yes, an error message is displayed, and the wage W is set to 0. This is because security personnel are not allowed to work more than 70 hours a week. 2. If the hours are less than or equal to 40, we are in the basic case. The wage is calculated simply as W equals H times R. This means the employee is paid the normal hourly rate for every hour worked. 3. If the hours are between 41 and 60, the wage is split into two parts. First 40 hours are paid at the base rate 40 times R. Remaining hours, that is, H minus 40, are paid at 1.5 times the base rate. The total wage becomes W equals 40 times R plus H minus 40 times 1.5 times R. 4. Finally, if the hours are between 61 and 70, there are three parts. First 40 hours base rate. Next 20 hours 1.5 times rate. Remaining hours double the rate. So the full formula is W equals 40 times R plus 20 times 1.5 times R plus H minus 60 times 2 times R. This structured logic ensures that wages are calculated correctly for all valid input ranges. Using if-else conditions in Java makes the code easy to read, flexible, and accurate. After this method runs, the variable W will hold the final wage to be displayed. Let's now go over the display method. This is the final step in the program, where we output the results after calculating the wage. The method starts with a simple empty println to create a space before the output. Then, we print the headings, name, hours, and wages, clearly showing what each column represents. The dashed line below the headings improves readability and separates the title row from the data. The real formatting magic happens in this line. System.out.printf%10s%10d row p%.2f\n h w. Here, we use printf instead of println to format the output neatly. 1. %10s tells Java to print the string n left aligned within a 10-character width. This ensures that names appear in the first column with proper spacing. 2. %10d is used to print the integer h, again left aligned in a 10-character space, which helps align the hours column. 3. Row p%.2f is used to print the wage W as a floating point number, rounded to 2 decimal places. This makes the wage amount look like a real currency figure, such as 7,750 rupees and 50 paise. Altogether, this method gives a professional and clean output, suitable for any application that deals with salary slips or wage reports. Once this method is called in the main method, the program is complete, and the user sees the final result on screen. This slide shows the complete Java program for the security class. It includes everything: the variable declarations, input method, calculation method, display method, and the main method that runs the program. Let's go through it quickly. We begin by importing the scanner class, which is used for reading input from the user. Then, we declare the class security with 4 instance variables, n, h, r, and w. The get method accepts the name, hourly rate, and number of hours worked using scanner. The call wage method contains conditional logic to compute the total wage based on different brackets of hours. The display method prints the result in a formatted table using system.out.print for neat alignment and currency formatting. The main method is where everything comes together. We create an object of security and call the input, calculation, and display methods in order. This full program demonstrates how Java can be used to simulate real-world salary calculations using classes and object-oriented programming. It's modular, logical, and easy to test with different inputs. In this slide you will get the full program link which you can execute the entire program. Also, program link is available in the description box. Let's take a closer look at the variable description table, or VDT, which helps us clearly understand the purpose and data type of each variable used in our Java program. 1. The first variable is n. This is of data type string and is used to store the name of the security personnel. Since names usually include text, we use string to handle alphabetic characters. 2. Next, we have h, which stands for hours worked. It's of data type int, because hours are always whole numbers, like 35, 40, or 65. 3. Then comes r, which is the hourly wage rate. It is declared as a double because the rate might be a decimal value, such as 100 rupees or 150 rupees and 50 paise. Using double allows us to store both whole and fractional values. 4. Finally, we have w, which stores the final wage calculated after applying all conditions. This is also of data type double, because the result will most likely be a monetary amount that requires decimal precision, like 7,750 rupees. Together, these four variables, n, h, r, and w, are the building blocks of the security class. Understanding them properly helps in writing correct logic, preventing type errors, and organizing your code better. Always remember, choosing the right data type for each variable is an important step in program design. Let's now look at a sample output of the Java program in action. Here, the program begins by prompting the user to enter three inputs. The name of the security guard, in this case, Ravi. The hourly wage rate, entered as 100 rupees. And the total hours worked during the week, which is 65 hours. Once the input is provided, the program calculates the total wage using the call wage method. Since Ravi has worked 65 hours, the wage is calculated in three parts as per the wage rules. 1. First, the initial 40 hours are paid at the normal rate. 40 times 100 rupees equals 4,000 rupees. 2. Next, the following 20 hours are paid at 1.5 times the rate. 20 times 150 rupees equals 3,000 rupees. 3. Finally, the remaining 5 hours, from 61 to 65, are paid at double rate. 5 times 200 rupees equals 1,000 rupees. 4. When you add all of these, 4,000 rupees plus 3,000 rupees plus 1,000 rupees equals 8,000 rupees. The key takeaway is that the program correctly applies tiered wage calculation and presents the result in a well-formatted table with name, total hours worked, final wages with currency symbol and 2 decimal places. This output proves that the program is working as intended, handling input, performing calculation, and producing a clean, readable result for the user. Let's quickly revise what we learned through this Java program. 1. We created a class called security with 4 instance variables, name, hours, rate, and wage. 2. The get method accepted input using the scanner class. 3. The call wage method used if-else conditions to calculate wages based on normal rate for the first 40 hours 1.5 times rate for the next 20 hours 2 times rate for hours beyond 60, up to a maximum of 71. The display method used print for formatted output. 2. We also handled invalid inputs by checking if hours exceed 70. This program helps build core Java skills, class design, input/output, decision making, and formatting, all in one practical example. Thank you so much for watching this session on class as the basis of all computations using Java. I hope the explanation made the concept clearer and more enjoyable for you. All the important components, the question, algorithm, Java program, variable table, and output, are available in the description box below. If you found this lesson helpful, don't forget to like, share it with your classmates, and subscribe for more easy-to-follow programming tutorials. Every share and comment encourages more students to learn with clarity and confidence. Keep practicing, keep building, and remember, your journey to becoming a great programmer starts with mastering the basics. See you in the next session, and as always, happy coding!